In the 1920s, astronomers believed the entire universe was the Milky Way. Edwin Hubble proved them wrong. Using a single telescope and faint starlight, he showed that galaxies exist beyond our own, and that the universe itself is expanding. Welcome to Mattermosaic, piecing together the universe, one discovery at a time. Today's story follows a man whose observations transformed modern astronomy and changed how we understand our place in the cosmos. This is the story of Edwin Hubble, the astronomer who proved that the universe is far larger, older, and more dynamic than anyone had imagined. Edwin Powell Hubble was born in 1889 in Marshfield, Missouri. His early life showed no obvious sign that he would redefine cosmology. He was an accomplished athlete, excelling in basketball and track, and later studied mathematics and astronomy at the University of Chicago. After earning a Rhodes Scholarship, Hubble studied law at Oxford University, following his father's wishes. But the pull of science never left him. After his father's death, Hubble returned to astronomy, completing a PhD at the University of Chicago and joining the Mount Wilson Observatory in California in 1919. Mount Wilson housed the most powerful telescope of its time. The 100-inch Hooker telescope, perched above Los Angeles, allowed astronomers to see deeper into space than ever before. At the time, the universe was believed to consist solely of the Milky Way galaxy. Spiral nebulae were mysterious objects whose true nature sparked intense debate. Some astronomers argued they were forming star systems within our galaxy. Others suspected they were distant island universes, but no proof existed. Hubble set out to settle the question using a new observational approach. He searched for Cepheid, variable stars inside spiral nebulae. Cepheids are stars that pulse in brightness at regular intervals. In the early 1900s, Henrietta Leavitt had discovered a precise relationship between a Cepheid's pulsation period and its intrinsic brightness. This made them reliable cosmic distance markers. If Hubble could identify Cepheids in spiral nebulae, he could measure their distance. In 1923 and 1924, Hubble identified Cepheid variables in the Andromeda Nebula. The result was undeniable. Andromeda was far too distant to be inside the Milky Way. It was a galaxy of its own, containing billions of stars. The universe instantly expanded from one galaxy to many. Humanity's cosmic address changed forever. But Hubble's most profound discovery was still ahead. Throughout the 1920s, astronomers had been measuring the spectra of galaxies and noticing something strange. Most galaxies showed redshifted light. Their spectral lines were shifted toward longer wavelengths, suggesting motion away from Earth. Vesto Slipher had measured these redshifts years earlier, but no one understood their meaning. Hubble combined redshift data with his distance measurements. In 1929, he published a groundbreaking paper showing a clear relationship. The farther away a galaxy is, the faster it is moving away from us. This relationship became known as Hubble's law. The universe was expanding. This discovery carried a radical implication. If the universe is expanding now, then in the past it must have been smaller, denser, and hotter. Although Hubble himself was cautious about interpretations, his observations laid the foundation for the Big Bang theory. The universe had a beginning. The expansion of space was not like an explosion through space. It was space itself stretching. Galaxies were not fleeing from a central point. Every region of the universe was moving away from every other region. This idea reshaped physics, cosmology, and philosophy. Hubble continued to refine his work throughout the 1930s and 1940s. He developed galaxy classification systems, separating galaxies into spirals, ellipticals, and irregulars. This tuning fork diagram remains a fundamental framework in astronomy today. He also worked closely with Milton Humason to extend distance measurements deeper into the cosmos, pushing observations to unprecedented scales. Despite his monumental impact, Hubble never received a Nobel Prize. At the time, astronomy was not considered a Nobel-eligible discipline. Yet, his legacy became inseparable from modern cosmology. Decades later, when NASA launched a space telescope above Earth's atmosphere in 1990, it was named in his honor. The Hubble Space Telescope would reveal galaxies forming in the early universe, measure cosmic expansion with precision, and provide evidence for dark energy accelerating that expansion. Hubble's discoveries also reshaped humanity's sense of significance. Earth was not at the center of the solar system. The solar system was not at the center of the galaxy. And the galaxy was not the center of the universe. Each revelation pushed humanity further from cosmic centrality while expanding our understanding of nature's scale. Edwin Hubble did not invent new equations or propose speculative theories. He let the universe speak through light. His genius was patience, precision, and the courage to follow evidence beyond accepted belief. The expanding universe is not an abstract idea. It is measured, observed, confirmed. And it began with faint points of light captured on fragile glass plates atop a mountain. Hubble showed that discovery is not always about creating something new. Sometimes it is about seeing clearly what was always there, waiting for the right question. This is Mattermosaic, piecing together the universe, one discovery at a time. If this journey through the expanding cosmos inspired you, like, share, and subscribe to support science storytelling grounded in evidence and history. And stay with us, because the universe is still expanding, and so is our understanding of it.